Thank you for staying tuned, and you're welcome to my page where we do our best to simplify the practice of quantity surveying. Uh, on this episode, we shall be analyzing and building up unit rate per kg for steel structural frame. And as you can see on my screen, I did a simple sketch of a girder beam that is fabricated using a 75 by 75 angle bar by 8 mm thick angle bar, and the weight per meter is a 9.8 kg per meter, and the jointing is welding. Before we proceed, I want us to understand the logics and the steps we needed to take when building up rate for structural steel. Structural steel is divided. The work of structural steel is divided into three stages. The first stage is the cost of the material and the cost of fabrication, including the cost of transporting this material, fabricated material, to site. While the next cost item is the painting of this material, including wire brush or sandblasting. Then you apply the primer and the finish coat. Then while the last stage is the installation of this fabricated material on site. So these are the stages of analysis you need to do before arriving at the cost per either ton or kg of your kilogram of your structural member. Like I said I have a sketch of a girder beam that has a span of 7.5, and the height is 1.2. It has a vertical stroke, 6 number vertical stroke, and 5 number the diagonal strokes. Then it has a 2 tie of 7 meter, both bottom and top. And I brought out I did blew the jointing for us to understand how the welding was done at each joint. And this is a typical joint of the girder. And as you can see on the screen, the vertical stroke is welded in 3 locations. You can see the red color indicating there was a welding here, another welding here, and the bottom. While the same thing, the horizontal stroke, you have it is welded on this location, and the bottom. So the welding is in 3 locations, and this is what is repeated in all the joints. So why I had to bring this out is for us to have an idea of how it's being welded. So when we are calculating the quantity of electrode that will be used for the entire job, you should have an idea how we came about it. And it is assumed that this girder is 20 in pieces, fabricated in this form, 20 in pieces. So what we needed to do first is to compute the quantity for one, then we multiply by 20 to give us the total tonnage of what we're expected to fabricate. So, like I did said, we have five diagonal members, while we have 6 vertical strokes, then 2 tie, bottom and top. And the computation for the diagonal slope is this: you have the length of the bottom angle, which is 1.5, the height. Since a right angle triangle, the height is 1.2. You square the length, you square the base, the height, then you get your square root, which is 1.92. Then this is what is done here. Like I did told us, the tie is top and bottom 2, and the length 7.5, and the weight per meter is 8.99 per meter. So you multiply it, you have your weight for the two top and bottom tie. The vertical stroke is 6 number, the height is 1.2, the weight is per meter is 8.9, and you multiply, you have that. The diagonal is 5, it's 5 number, you have the length is 1.92, and the weight per meter, because the whole members is fabricated using the same 75 by 75 angle iron. So I sum the total weight for all of the members. I have 283.08 kg. Then you multiply by 20 number of girder, you have 5,661.23 kilogram. So now this next stage is the computation of the electrode. The computation of the electrode, like I did told us, we have 3 points we are going to weld in each of those, each of the members. Then for the tie beam, we are going to weld, because the total length of the girder is 7.5, and the length of one angle iron, the way it comes from market, is 6 meters. So you needed to chop off additional 1.5 from another full length, then you join it to the 6 meter for you to get your 7 meter length. So, and you needed to weld the angle iron together, and the location you're going to weld is you're going to weld all through the 75 by the other 75 length. So like I did told us, the struts, I'm welding 3 locations, and the length is 75, and this length this way is 75 and 75, so it's 3 locations, and that is why you have the vertical strut, 3 points of welding. Then total number of points of welding is 12, because you have 6 struts and you have two locations, that is top and bottom, top and bottom, top and bottom. 6 by 2 gives you 12. Why the diagonal is top and bottom multiplied by 2 gives you 10. And that is why you have 10 locations where you're going to point of welding. Why the tie is 2 locations? Because it is just an angle iron. You're welding the 60, you're welding the 75, the other side of 75. So, and the location is 2 points. And the length for the welding, the length of the welding where you're going to weld is 75 mm, because the angle iron is 75. Why the diagonal, after computing it, it's 0.08, it's longer than the angle iron, because it is in diagonal shape, so it's not straight, that will give you the same length of 75. So by the time you compute the point of welding and the number of points by the length of the welding, it gives you 2.7, this 2.4, this other one is 0.3. So the total length of welding is 5.4 in one girder. If you now multiply it by 20 girder, you have 108 meter length of welding that you need to do for the 20 girder. Then a stick of electrode, which is usually 400 centimeter long, can weld proper welding, because we have different kind of welding. We have the flat welding, the angular welding, the butt welding. So in this case, we are going to do flat, and it's a single pass. That's why you see I indicated welding. It's a flat welding and a single pass. Why is it a single pass? Because I'm just welding once. It does not require that I go 1 or 2 passes or 3 passes for me to fill up, because it is not the butt welding that I needed to fill the gap that I've created. So it is a single pass. So it's going to weld a 10 cm long of welding using 1 electrode. So now if I divide the 108 meter long by 10 cm that 1 electrode can cover, it will now give me a 1080 pieces of electrode. So now for me to get the electrode I'm going to use per kg is to divide the total of 1,000 by the total kilogram, which is the 5,661 kg. So now I now have a 0.19 piece per kg. So also for the cutting discs, in this case, I am not using gas to cut. I'm not using hacksaw to cut. I am going to use a cutting machine, a cutting disc with a machine to cut my members into pieces to the sizes that I want. And what I did for us to understand this, all of this data, I now drew some series of line here. I now said a length of angular iron is 6 meters, and now I'm expected to, in each girder, I'm expected to cut 6 pieces of the of 1.2 from each of the from for one each pieces of 6 pieces of 1.2 to make up for one girder, while I needed to cut 5 pieces of 1.92 to make up the diagonal. Then what I did now is to now say in 1.5, how many, in 6 meters, how many cut will I cut to get my 6 pieces? So now I now assume from this vertical line to this vertical line to this vertical line to this vertical line is each cut. So now my first cut from the edge, from the beginning, is I'm going to cut 1.2, and I'm cutting here 1, I'm cutting here 2, I'm cutting here 3, and I'm cutting here 4. So I have 4 cuts, but I'm going to get 1, 2, 3, 4, 5, meaning that I need 6 pieces of the vertical members to make up one girder, which means I'm going to take another length and I'm going to chop off 1. So which means I have 1 cut, 2 cut, 3 cut, 4 cuts, then 5 cuts for this vertical stroke. That's why you have 5 cuts. You have 5 cuts. Then for the 1.9, which is the 1.92, which is the diagonal cut, I assume also I'm going to cut 1 cut, 2 cut, 3 cut. Why this is off cut? Because if you sum the total length of this 3 I have chopped up, it is 5.7. So the remaining off cut, which is less than is 240 0.24, which is off cut, that will be thrown away. So I've succeeded in getting 3 pieces from. I've succeeded in getting 3 pieces from one length. So I need to cut another 2 pieces from another length. So I'm going to cut 1 cut, 2 cut, 3 cut, then 4 cut, 5 cuts. And that is why you're having 5 cut also for the diagonal. Why the tie? Like I said, I'm going to have, because I'm going to join a 1.5 to the 6 meter to have my 7.5 length long girder. So I'm going to have 2 cuts. I'm cutting 1 from a full length in 2 places to join the 2 tie. So I now have the point of cut. This point of cut is because it is an angular iron, and the thickness of this angular iron is 8 mm. I'm going to cut 750. Then I'm going to cut 750 this way. So which means I have an angular iron. I have an angular iron in this manner. I have an angular iron. So I have an angular iron. I'm going to cut through this one, and I'm cutting through this location. So it's 2 location of 0.75 I'm going to cut. So I am going to cut 2 of the location. So that is why I have this 2 because it's an angular iron. I'm cutting through this 750 and 0.75 and 0.75. That's why I'm having this 2. And the length of this 0.75 is the length is 0.75. Why you have 0.75? That's why it's 2. 2 multiplied by this gives you this length and this length. So if I multiply it together, I'll have a 0.3 length, a 0.75, and a 0.8. So if you sum all the cut I am going to do, it's 1.85 meters. if you multiply it by if you multiply it by 20 girder, you're having 37 meters total cut I'm going to do to make for my girder. Then a cutting disc of a 230 diameter cutting disc can cut 8 mm thick plates. The length is going to cut a 1.2 meter long 8 mm thick plates. So I now divided my 37 meter by 1.2, give me 31 pieces of cutting discs that I needed, that I'll be needing to fabricate, to cut all the materials I needed to cut during fabrication. So now, for me now to get the quantity of cutting discs that I'm going to use for a kg of 1 kg is for me to divide the 5,661 kg by the total discs I will be needing for the whole work. So I have a 0.01 piece that I'm going to use. Then coming to the fabrication, this is if it is an on-site or off-site fabrication. You have to compute the labor for the fabrication for the girder separately from the computation of the labor for installation. So in this case, I have assumed that I'm going to spend 10 days to fabricate all the 20 girders, and I will be needing 5 welders, and I'm going to be needing 3 labor that will be helping them in either moving one thing or the other. And they are all going to spend 10 days to do the fabrication. And the cost for the welder is 10,000 per day. Why the labor is 4,500 per day. So if you multiply the number of welders by the days by the amount, will give you this amount. So the cost for the fabrication, whole fabrication, is 635,000. So now for you to get the cost per 1 kg is to divide the 5,661 by the total cost of the labor for fabricating. Then you have a 112,017 kobo. So now we are done with cost of material, analysis of cost of the material and the labor for fabricating. So now we want to now compute, we want to analyze our paint and the cost of painting. So the first thing I did is to build up the unit rate for gloss paint. So what I did is the description, assume the description is 2 coats of gloss paint and 1 coat of primer, and the coverage area for a 4-liter gallon of gloss paint, 2 coats, is 15 square meter, while the primer 1 coat is 40 square meter, while the solvent, meaning the thinner you're going to use to lighten the paint before either using it as for spraying or hand painting, the coverage area is 160. Of course, you're going to apply your wastage, and the cost per gallon for the gloss paint is 35,000 naira. This 8,500 for primer, while the solvent is 4,500. So 4,500. If you compute it, you have a 2,825 naira 16 kobo per square meter. Therefore, the material, why the labor of course is 200 naira for your wire brushing and your painting per square meter. So the cost will now come to 3,025 naira 16 kobo per square meter. So this will be kept aside. Then we'll now come and calculate the surface of the members that we needed to paint. So what we did now to say, you have 2 tie beams, You have 6 vertical strokes. You have 5 diagonal strokes. Then the length is 7.5 for the beam, 1.2 and 1.9. I'm going to go back to this to explain how the surface area is for. I take us back to this angle. This is the angle iron. You are going to paint back of this and paint in of it, so it is 2. You are going to paint the bottom also, back and bottom, so it is 4 portion. 1, 2, 3, 4 of 0.75 that you're going to paint. So that is what I did here. This is 0.75 by 4. So this is the square area for one girder, 9.54. So if you multiply it by 20 girder, you have a 190 square meter, 190.83 square meter. So if you now multiply the cost per square meter of the gloss paint, including primer, by the total square area, it will give you 577,284 naira 87 kobo. Then also you divide it by the total weight. If the bill is, if the painting in the bill is either price in square meter, in kg, you divide it by the kg. You have this as the cost per kg. But if it is in square meter, if it is cost per square meter, so this will be the quantity in the bill. Then this will be your unit rate that you're going to apply on the quantity to arrive at what you're going to have. Even if you, if you approach it in this manner, you're still going to arrive at this amount. So it is still the same thing. So whichever way the bill is being written, that is how you're going to approach it. So now this is the painting. Then of course, this is cost of transporting the material if it is an off-site, fabrication. I needed to transport this material to site. So the total weight of the material is 5,661 kg. So in this case, I took a 10-ton truck, high-up truck that has a crane, a mini crane attached to it that can load it from the off-site fabrication yard to the site and I'll equally offload it. And the cost is 100,000 per day. So if you divide that by the total cost for the total weight of the material, you are having 17 naira 66 kobo per kg. Then the cost of installation that I said it has to be treated separately. The number of days that my analysis, or by virtue of the experience I have looking at the drawing, 4 days I will be able to install. So I assume I'm going to spend 4 days to install it. I need 4 welders and I need 1 welding mate. Then their cost is 10,000 and the 4,500. So if you multiply, you have this amount, you divide by the total weight, 5,661. You have 31 naira 44 kobo per kg. So after getting all of this your analysis, then let us now come and build up the rate. Now this is the material basic rates in the market. The angle iron delivered to site. Say you are using a supplier to deliver this material to site. You are asking a supplier to bring it to site. It's going to cost you 49,000 per length. And for the electrode, a packet is 16,000, and the quantity inside the packet is 80 pieces, while the cutting disc is 1,500 per piece. So for you to get your cost per kg is for you to compute the length of the angle iron in the market is 6 meters. And since we understand that the weight per meter is 8.9 kgs, to multiply 6 by 8.9 kg to give you the weight of one length. So you now divide the cost, your cost per one length, by the weight, total weight. It will give you the cost per kg, which you are having in 917 naira 60 kobo per kg. Why the electrode? You divide your 16 by 80 pieces, give you 200. Haven't gotten this. The angle iron now, it is 1 kg we are computing. Of course, we are adding waste because when we are chopping off these members, we're going to have some off cut. So a 5% waste. Then so multiply by 917 gives you, plus the 5% gives you 963 naira 49 kobo. Why the cutting discs? These are all links from all the computation we have done in terms of the analysis we did. Like for the cutting disc is 0.01 piece that I need per kg. Why for the electrode is 0.19 per piece per kg. Why the fabrication you need the cost is 112 naira 17 kobo per kg. So I now have electrode, and I of course I considered waste. Electrode per piece is 200 naira. So I'm using less than 1 piece to weld. That is what constitutes the electrode in 1 kg is 40 naira 6 kobo. Why the transportation of these members to site 17 naira 66 kobo. So if you sum these two amount, if you sum the whole of this amount for, you have your cost of material, which is a 1,029 naira 79 kobo. Then of course our computation of labor cost for fabrication 112. Then our cost for painting, which is 101 naira 97 kobo. Then our cost of installation, which is 31 naira 44 kobo. Then if you sum all of this cost, labor, painting, installation cost, it will give you a 1,000 1,275 naira 33 kobo per kg, which is also, if you want to convert it to cost per ton, you should multiply by 1,000, which is a 1,275,366 naira 97 kobo. So now what I did for that, I now took an extreme position, saying if you say the steel structure, you're only moving to sites to do steel structures. I now give us an idea of the kind of preliminary items, indirect costs you needed to consider. Say if it is an all-in rate where you needed to incorporate your indirect cost into the cost. So now I came below. I now said indirect. I considered all the items I'm going to use. I need a welding machine, an industrial welding machine. I need 2 numbers, and it's going to spend 14 days. And cost per day, this is quantity. This is this is rates, and this is amounts. So this is the rates. So the total for the plant and equipment is 4.2 million. Then your indirect staffs. Indirect staff, your engineer, supervisor, manager, security. You can go on and on depending on the complexity of the project and the kind of personnel that you needed to make the project a success. So, and they are going to spend 14 days as well, the quantity, and this is the This is the rate and the amount. So the cost for the indirect staff is 716 naira, 153 kobo, 53 naira, 85 kobo. Well, then you consider the safety material. You have the coverall for the workers, you have your safety boots, you have your hard hats, you have your hand gloves, safety harness, that is safety belt, eye goggle. So you consider all of it, and all of that. The cost is this. So also you consider your accommodation, security hut, you have your canteen. If there is temporary fence, you compute it, your sanitation, you have the cost for building up a temporary toilet and the sockaway pit and the bedroom and all of that. So let's assume after considering all your preliminary items, you came to this amount, 5,422,522 naira, uh, uh, 522,152 naira 85 kobo. You further divide the total weight by your indirect cost to give you 957 naira 77 kobo per kg. So you bring this up here as your indirect cost. Then if you add your indirect plus the cost of your material, installation, painting, and everything. So it will be coming to a 2 million, which is equivalent to 2,233 naira, 33,135 naira 84 kobo per ton. Per ton. Why this is per kg? This is per kg. So I believe I wasn't too fast to help us understand all what I have done. If you have any gray areas that you want me to either do a video to explain further, you can as well drop a note on my page. You can ask me to further explain the areas that you were able to catch up, as I was being fast so as to enable me shorten the video. So, but if it has helped you understand further how to build up your rate for a kg per kg of a steel frame, please don't complete watching the video without leaving a like, share to friends and colleagues, and above all, hit the subscription button to encourage me to continue to do more. Watch out for another section where I'm going to do this using a more bigger member. I'll be using, say, a H channel or a I beam, or I'll still do other videos showing us how to compute the rate for base plates, sets, stiffeners, and the likes. So bye for now. See you next in the next episode.